Okay, in this video, we are going to consider the arc on the curve y is equal to natural log of x squared minus 1 from x equals 2 to x equals 8. And then we'll do three things. First, we'll find the arc length, and then we will take the arc, rotate about the x-axis, and find the surface area. And then we will take this arc, rotate about the y-axis, and find the surface area. And look at the little notes right here I've prepared for you guys already. And in the videos right here, I will just show you guys a setup, and you guys can use your graphing calculator to do the integrals, all right? Sometimes when you set an integral for this kind of things, the integrals is either really hard to solve or impossible to solve. So just use a calculator for it, and pay really close attention to the details, right? Because maybe on the exam, you get just one part for the question, and you have to remember the setup for that part, and then use a calculator to do the integrals. All right, enough talking. Let's go ahead and do part A. Well, for the arc length formula, as you can see, we have two versions. This right here is just a small change amount in the arc. So I call this to be the dl. And it depends on if we have y as a function of x or x as a function of y. In our case, we have y as a function of x, so we'll use this version for it. Notice I just have to factor out the dx squared and then do some algebra, and we can end up with this side, right? So here we have the square root, but let me put on the integral first, because this is just a small change in the arc length. You have to use integrals to add them up. And we will have to put on the square root. 1 is 1 plus parentheses. Notice that we have to get our first derivative. Let's look back to here. I will differentiate this, which we get dy dx. And the derivative of natural log of something is, of course, 1 over the inside. So we have x squared minus 1 in the denominator. And don't forget your chain rule. Multiply by the derivative of the inside, which will get you 2x. And we will just put that down right here. Let's write down 2x over x squared minus 1. And we square that. And we also have to have the dx. And as you can see, because of the dx, we know that we have to set this up to be going from x equals to 2 up to 8. And this right here is it. Again, use your graphing calculator, right? Just practice how to use it so you can do that later on, right, on the exam also. So maybe you guys can leave a comment down below and let us know what the answer to these questions are. And whoever can get it right, I'll pin your comment, right? That would be cool. Okay, next, surface area. Well, in this case, the capital S stands for the surface area, and ds is just a small change amount in the surface area. Notice the formula is 2 pi r. It's just like the circumference formula, right? And in our case here, we are going to take the arc and rotate about the x-axis. So when you do that, the radius is the y value, right? This right here is the y value when you have this rotation here. And you take the circumference, right? 2 pi r is a circumference formula, but you have to multiply by dl. And the reason is because you have to make this slanted and then rotate that. And that's pretty much a quick explanation in a way that you can remember this formula nicely. And you guys can see my other videos for detailed explanation for why that formula is true. But anyway, enough talking. Here we go. We have to have the integral, of course, 2 pi. When we rotate about the x-axis, the radius is, again, the vertical distance, which is the y value. So let me put down the y, and then we put down the dl, of course. And you see that we have to have the dl here. I cannot set out the limits of integration yet. Well, we have to look back to first part. And if you are doing this question like from scratch by itself, then you have to look back to see what kind of function you have. Because we have y as a function of x, we will have to use this version for the dl, right? So let's see. Integral, we have 2 pi is still 2 pi. We have this y, but again, for the dl, it's pretty much the first part, just the inside without the integration, of course. So let me put that down right here. We have the square root of 1 plus parentheses 2x over x squared minus 1, and you square all this, and you have to have the dx on the very outside. And now here's the deal. Earlier we talked about it. When we rotate about the x-axis, the radius is y. But now we are in the x world. So we have to actually look back to what y is in terms of x. So we have to actually write this down because again, y is not invited in the x world. So write down this y as the natural log of x squared minus 1, like this. And because we're in the x world, we are going to go from x equals 2 to 8, like that. So this right here is again the setup, and you guys just use the calculator to do the approximation for us. So that'll be cool. Okay. All right, okay, so it's okay. Anyway, to find the surface area, if you take the arc, rotate about the y-axis, the only thing different is that when you do it this way, the radius is horizontal. So it's actually the x values now, right? So I will write this down right here for you guys. This right here is equal to the integral 2 pi, and again, in our case here, it's x, right? So this part, the radius, you have to think about it depending on how you rotate. And the dl is still dl, so I will just put that down. And you'll see this is actually really nice because you can just have the integral 2 pi. Well, let me write down the dl for you guys first, which is still this part, the square root of 1 plus parentheses 2x over x squared minus 1 squared, and then you have the dx on the outside. But because we are in the x world, this x is totally fine. You can just go ahead and put down the x. So that will be your legitimate integral. And of course, don't ever forget your limit of integration. In the x world, we go from 2 to 8. So that's it. Again, you do it on your TIT3 or TIT4. So that's it. All right? Hopefully you guys will like this video. If you are new, if you haven't subscribed yet, well, just watch my video anyway. Anyway, that's it.